Hey everybody, welcome back to the channel. Got a fun episode for you guys today. We're going to resharpen this roughing end mill. Now this particular end mill has a really bad chip on the end. This whole bit is missing, and that used to be the tooth that would pass through center to make it so this thing could drill. So all that's got to be repaired, as well as just sharpening the sides. I've got my air bearing up here. Don't actually use air with it, but I've freshly oiled it so it's running nice and smooth. First thing I want to do is get this table running true axially. I had this offset to grind a taper on this new arbor that we just finished making, and so I want this to run zero so that the graduations on all my fixtures, the zeros are accurate. There's 4 bolts that clamp the rotation of this table. There's 2 on this end clamp here, and there's also there's 2 at the point of rotation, 1 on each side of the table. Now I'm positioning my pointer. It's important that the pointer be to this side of the actual cutting edge of the grinding wheel where the work is happening. If this if this point is directly across from this cutting edge, it'll cause the very tip of the tool to get kind of goofy. But right now it's too far away, and this won't get us all the way to the back of the tool. So we're going to come this way till we're just to the right-hand side of the actual part of the wheel that's doing the cutting. Now I'm going to hold this in a collet, tighten that down, and then we'll adjust it so that it's just on the tooth. We want to grind the tool, not the little pointer. So we just want it about like that. And now we will set our end stop. I'm going to put a little bit of marker right here so I can exactly pick up my primary clearance angle. The primary is this first narrow little guy here. So we're going to pick it up first, remove the damage, and then we'll come put the secondary clearance angle on afterwards. So it looks like we're picking that up nicely. Just going to run the dial on it, make sure we're happy with that. Here we've cleaned up that primary clearance angle, and you see, same thing. It's got 4 or 5 thou on there, so that should be fine. Now we're ready to sharpen up the sides of this thing. So I'm going to get my air cleaner going, get the grinder going. There's our primary clearance angle all cleaned up. The face is nice and fresh. The cutting edge is free from chips. Now we're going to move on to our secondary clearance angle in here. think this will get us pretty close, but I am going to put some marker on there again. Oh, it's already got marker on it. I'm good to go. And I'm just going to get that running as close as I can to what's existing. That does it for the sharpening. She's nice and sharp. We've got our primary clearance angle on there and our secondary clearance in behind it. I'm happy with all that. So we're going to move on to the next step, which is blasting the end back and getting rid of this huge chip here so that we can recreate a drilling style end on this thing. While I still have this thing all set up to achieve these angles, I'm going to pull this thing out, give it a deburr, and make sure that I am positively happy that there's no chips or damage remaining on the cutting edge. Well, I'm just locking this thing out so it can't be all moving around, and then I'm going to take it off of here and make the next setup. We're going to be grinding this end back to get rid of this chip. But this end, I'm exaggerating, but this end is going to be ground at an angle like this because we want the outsides to touch before the middle does. That's just how end mills are built. So because we have a taper involved here, step one is to get our spindle exactly at center height and exactly true to the traverse of the table. There's a 0 on here, which will get me close, but I certainly wouldn't trust that. I'm going to actually use my dial and make sure it's absolutely running 0. Pretty darn close. I'm going to 0 my height gauge off of the table. Just double check that, and I do happen to know that the center height of this machine is 4 1/8 inches. I'm coming up to the 4, to the 1, and to the 25. So that is exactly where I want. That's exactly where center is. This is exactly 3 inches, so I'm going to add another 1.5 inches to this. That'll bring me to the top of this, and that's where I'll do my touching off. Now that I know where I want the top of my spindle to be, I'm going to set a 0 to that. And you can see we've got to come down quite a ways to get where we need to be. Come up about 9 thou. A little too much. There we go. Get my motorized work head up here. By tightening this clamp at the back here, I'm pulling keyways in this T-slot into place. And because we've dialed this table 0, I now know that I can trust the graduations on this base to be pretty darn close. And so what I want to do is get 3-degree offset. Put my 3/4 inch collet in there. Get my end mill in there. Now we're going to want to set a stop real close to center, but actually we've got the slightest little radius on this corner of the grinding wheel that was put there when we actually did the sharpening on the outside of this guy. So we're going to use that little radius to leave us the tiniest little point. We're going to leave a little point sticking up right in the middle. So we're not going to grind all the way to center. We're going to stop just shy by as little as possible to make a tiny little point, and that'll be a visual reference when we go to recreate these tooth faces down in here. The grinding is happening while the teeth are over on this side, and it's at that 3-degree angle, and we're going to grind this back until we remove all of this damage here. So that's the next step. I don't know if you can see it, but right in the middle here is the tiniest little point, and I'm leaving that behind on purpose so I can use it, you know, as a gauge when I go to recreate the faces of these teeth. I'm just going to dress my wheel so that I'm positive it's running perfectly true to the table across this face. We've got all that damage off of there. You can see all these helical cutting edges make it all the way to their respective corners. All that damage is gone. But now in the process of doing that, we have changed how the end of this thing looks. Okay. So next we're going to make a setup that puts a notch, a tooth face, directly through the center of this little bump sticking out and right exactly to the edge of the tip, right at the cutting edge. So we want a straight ground line right from there to there that passes all the way through center and on some, and that'll become the tooth that allows this thing to drill. The other two teeth are just going to get clearance knocked in them so that they're not interfering. So on to the next setup here. This is coming off, and my sensitive work head is coming on. Next thing I need to do is get this spindle running 90 degrees to where it is now and dialed in. Okay, that's running 0, happy with that. Get this wheel off of here.
What's fine?
Spider web or something. So this isn't exactly what this wouldn't be my first choice of wheel to use. This was actually a plain style wheel, but it's nice and coarse, and I need a really coarse wheel because I'm plunging, and plunging causes things to really heat up. Looks like I had an angle on both sides of this and then relief behind. So what I'm going to have to do is dress this back to get rid of that first little bit with the angle, and then I'll put more dish in here for clearance because I only want it cutting right at the very outside edge. So I'm going to get that set up in here, get that dressed up so it's ready to put these notches in for us. So I'm an idiot. I dropped this wheel on the floor, took a chunk out of it. It's possible it's cracked now. So what I'm going to do is I'm going to turn the grinder on. I'm going to run it for a minute. I'm going to stay the heck out of anything that's in line with this wheel. And as a general rule of thumb, I mean, back to my high school days, we were taught if a wheel will run for a minute without blowing up, you're good to go. So we're going to do that now. I'm going to run it for a minute, see if it blows up or not. And even if it doesn't blow up, I'm not going to put my head in line with this thing. I'll probably put some thick leather gloves on for when I do the dressing because my fingers will have to be in line with it. And I will dress the side first. My thinking there is that if it was going to blow up, it'll blow up with my fingers here, not in line.
Done yet?
Yeah, it's been running just about a minute now, almost a minute. It hasn't blown up. I honestly didn't think it was going to blow up. I've been doing industrial tool and cutter grinding for 35 years now. I've never actually seen a grinding wheel blow up. Not a single one. I've had all kinds of crazy things happen. The nut come loose, the wheel come whizzing off and shoot across the room. But I've never actually seen a grinding wheel blow into pieces. Not once. Getting my dust collector set up here. As I dress this thing, there's going to be a lot of dust, grit coming off it, flying all over the place, and I don't want to be breathing that in. I think this will be fine.
It'll be fine.
I'll get most of it.
You're doing it by hand?
Yep, I'm doing it by hand with my little diamond dressing bit.
All your chuck dings are gone now?
Yep, and it's all trued up, and I've got the angles I want on it here, and I'm just going to throw my dial on it quick and make sure that the outside edge is indeed higher than the rest of it. And yeah, that all falls away. So that is my highest point, which is what I want. This next fixture is called a sensitive work head, and it's used for, holding cutting tools as well as indexing them. It has 24 teeth on it, so anything that's divisible by 24 works with this, and of course our tool has 3 flutes, and so that works just fine. Now I do want to put something in here that I can dial off, something round, something that runs true. I want to get it running perfectly true this way and this way. And that's going to be important for what we're doing here. This next bit here is super important. We need this rotationally, we need this tip and this little bit we left behind, we need them perfectly in line vertically with each other. The way I'm going to do that is I can find my center height using my height gauge. So I'm going to find my center height from the table, and then I'm going to align a tooth to that center height. That's my center height. So what I'm going to do, I'm going to get this tooth at exactly center height here. And we'll be double checking that. Make sure it's bang on. Yeah, that's pretty good. Now I know that if I back this up 4 notches, 1, 2, 3, 4. Oh, sorry, 6 notches. Yeah, 6 notches. Now this is perfectly vertical. Now that we've got that running perfectly vertical, we're going to get this wheel in place to do our notching. You can see the back of this, the bottom, I guess, the back of this this cutaway, this tooth here is on, an angle about like, I don't know, 40 degrees or something. And so we're achieving that by having the grinding wheel off center. So this notch will be way deeper near the outside than it is near the inside. So once again, I'm using my little point that I left behind as like a gauge to get me on the center. Now if we zoom way, way, way in and you look just in front of my fingernail, you may or may not be able to detect the slightest little shiny spot there. What that is it's just a witness of this flat having come all the way through this little nub on center. You can see that's cut in half now. And this flat spot continues all the way out and just ticked this. But we'll remove that little tick when we put the end cutting angles on. This tooth face here is done. That's the one that passes right through center. That's going to be the one that gives us the ability to drill. And then we've got this guy over here. Its face is fine. we've got clearance in here like we need. But now we need some of this material here gone, so that only the one tooth can pass through center to do that cutting. So I'm going to come in with this wheel and I'm just going to stop shy of this little bit that we've left because I want that remaining. That's center. We need that to cut. I'm just going to get rid of a bunch of this over here on this tooth. I've just removed this material here. You can see we left our little center bit. We're past that still, so this tooth will drill. The other two are not designed to drill. Now we just have to put the clearance angles, the primary and secondary clearance angles on the end of this thing. I'm going to want this to the same 3 degrees that I had the motorized work head at. We'll be checking that with a dial because I don't want to go having to take off any more material than I really need to here. Well, now I'm setting this to 7.5 degrees, which is what I want for my primary clearance angle. Now I'm going to set this to 15 degrees and put my secondary clearance angles on. Just going to adjust my height here, get my wheel where I need it for this new angle setup. Should do. This is the secondary clearance angle that we're working on now. Just going to bring that up till the primary's about that long.
How happy are you?
Plenty happy.
Perfect.
I'll get this thing out of here and we'll take a look at it close up and talk about what we've done here. All right, so this is the tooth that allows us to drill, and this cutting edge extends slightly past center. The other teeth have some clearances ground into them. This one, you know, looks a little goofy in here, but basically I did have to create a clearance in between this tooth, and so that's where I chose to do it. Now, this is not a cutting edge. This is all well below everything else here, and so this goofy area is just all clearance. So that won't have an effect at all. Yeah, I'm good and happy with this. I think it's safe to say this will work mint. Well, that's it for today's show, guys. I hope you maybe saw something you hadn't seen before and hope you enjoyed it. And if you did, please like, share, and subscribe. Bye for now.